learners, welcome to this lesson. In this lesson, we are going to be learning about factorization. Factorization is derived from the word factor. In the previous lesson, we learned about how to determine or how to get the factors of composite numbers. Now, I want us to use the number 10. We got the factors of 10 and they were 1, 2, 5, and then 10. Now, out of these factors, some of them are prime numbers. 2 is a prime number, 5 is a prime number. So factors that are prime numbers are called prime factors. Okay? Prime factors. Now, when doing factorization, we use, or rather we express a number as a product of its prime factors. For instance, 10 can be expressed as a product of its prime factors. The prime factors in 10 are 2 and 5. So if we multiply 2 by 5, we actually get 10. So in this case, we say that we have factorized 10 and expressed it as a product of its prime factors. Now, when doing factorization, we use something that is called a factor tree. Okay? We use a factor tree. So how do we come up with this factor tree? So let us attempt one. Let us try to express 24 as a product of its prime factors. So 24 is divisible by the least prime factor that we know is 2. So what you have to do is to always test from the least prime factor. You try to divide the number given. So the least prime factor is 2. So 24 divided by 2 will be equal to 12. Okay? Then now we divide 12 by the least prime factor. The least prime factor is 2. 12 divided by 2, we get 6. Then 6, we divide it by the least prime factor, which is 2. So 6 divided by 2 will be equal to 3. So we can say that 24 will be equal to 2 times 2 times 2 times 3. This 2 times the 2 times 2 times 3. So like you can see, we have expressed 24 as a product, okay, of the prime factors in it. So you notice that the numbers that we have here are prime numbers. So they are prime factors. Now, this product can be expressed in something we call the power form. Okay? The power form. Now, the power form of 24 will be equal to, so we count, we have 2, then how many 2's do we have? 1, 2, 3. So we can write 2 times 2 times 2 in power form as 2 power 3 because we have 3 2's. Then we multiply by the 3. How many 3's do we have? 1. If it is 1, there is no need of writing, or you can just write here 1. Now we are going to do another example so that we can master the art of writing a number as a product of its prime factors and also expressing that product in power form. Example 2. So in this example, we are going to express 144 as a product of its prime factors. So we develop a factor tree. So we divide by the least prime number, which is 2. So 144 divided by 2 will be equal to 72. Then we divide 72 by the least prime number, which is 2. This will be equal to 36. Again, we divide by the least prime number, which is 2. 36 divided by 2 will be equal to 18. Again, we divide 18 by the least prime number, which is 2, and this will be equal to 9. Now, if you try dividing 9 by 2, you realize that 9 is not divisible by 2. Therefore, we move to the next prime number, which comes after 2. And that number is 3. So we divide by 3, 9, divide by 3, we get 3. And because 3 is a prime number, that means we cannot divide it any further. Therefore, 144 will be equal to 2 times 2 times 2 times 2 times 3 times 3. And that is how you express 144 as a product of its prime factors. Now, how can we express this in power form? So we have two numbers here. We have 2's, then we have 3's. So how many 2's do we have? 1, 2, 3, 4. So this becomes 2 power 4 times 3. How many 3's do we have? 1, 2. So this becomes 3 power 2. So 144 as a product of its prime factors is equal to 2 power 4 times 3 power 2. Notice how this is read: 2 power 4, 3 power 2. Okay, so now I'll give you a few examples, a few questions that you are going to use to test yourself on whether you can express numbers as a product of its prime factors. Now, having learned how to express numbers as products of their prime factors, attempt these 3 questions. So express 120 as a product of its prime factors, express 250 as a product of its prime factors, and finally express 140 as a product of its prime factors. Thank you and see you in the next lesson.